if you remember about our last class, so we were talking about chemical properties of alkenes, right? We were talking about chemical properties of alkenes, and now we are going to talk about again with that. Just look at over here what I'm going to start. Now the thing is, we are actually on the chapter alkene, and alkene is actually when carbon-carbon double bond is over there, and this is one of the very basic example of alkene, which is ethene, the first member of this family, right? We know that, bacho, that we can convert this into halogenoalkane. Halogenoalkane is also one of the homologous threes, right? In which we have the carbon-carbon single bonds and carbon and hydrogen single bonds along with a halogen over there, right? And we know one more homologous threes as it was a part of O levels as well, alcohol, right? So we can convert alkenes into these two homologous threes, right? I can convert alkenes into halogenoalkane. I can convert alkenes into alcohol as well, right? What I just need to know the double bond is going to broken down, right? The hydrogens are on their own places, right? The double bond is going to broken down and the hydrogen are on their own places. If I am going to react it with HBr or HCl at room temperature and pressure, so definitely the double bond breaks, and at one carbon there will be H, and on another carbon it will be Br, right? Same as it is if I am reacting it with steam along with dilute phosphoric acid, a catalyst at 350 degrees Celsius temperature and 100 atmospheric pressure. So we know that at one carbon there will be H, and on the other carbon it will be OH. This is what we were talking about in the last classes, right? We talk about the chemical properties. We know that we can convert alkenes into halogenoalkanes, and also we can convert alkenes into alcohols. Is that right, bacho? Right or not?
Yes, sir.
And these both reactions were known as electrophilic addition reactions, right? These both reactions were known as electrophilic addition reactions. We talked about this in the previous class, right? Now there is one more reaction which is new for us. Now what we need to know that this alcohol can convert back to the alkene, right? This alcohol can convert back to the alkene, as well as this halogenoalkane can also convert back to the alkene. This is what we need to do in our today's class. So these are actually chemical properties we were talking about in the last class. These were what? This is one of the chemical property of alkene. That was right. So that is why chemical reactions हमने इसको पढ़ लिया. Now this is what the way of preparation of alkene. So you can even prepare alkene. This is preparation of alkenes. You can prepare alkene by alcohols. Even you can prepare this by halogenoalkanes. Is that right, bacho, or not?
Yes, sir.
So we know that formation of halogenoalkane and alcohol from alkenes was like electrophilic addition reaction that we talked about in the last class. But now we are going backward. अब हम वापस जा रहे हैं. और वापस में क्या करना है, हमें अल्कोहल से हम अल्कीन में आना चाह रहे हैं और हैलोजenoalkane से हम वापस अल्कीन में आना चाह रहे हैं. So here what we need to do, बच्चों, here we need to do what? Just look at over here. We were talking about what if we have C2H4, we were reacting with HBr, and now it is going to form what? Halogenoalkane. In the last lecture we talked about this. Same as it is if we have alkenes, if we are reacting it with water, it is going to form what? Alcohol. That is what this is, addition reaction. You can see this, that two reactants are going to combine together and forming one product. Whenever two reactants combine together and give you one product, this is actually addition reaction. So this is fine. We were talking about these reactions as electrophilic addition reaction. But now we are moving towards backward. अभी हमें वापसी के रास्ते दिखाने हैं. जब वापसी के रास्ते में आप देखेंगे कि आपके पास अल्कीन बन रहा है और साथ साथ एक मॉलिक्यूल एलिमिनेट हो रहा है. You can see this in both of the backward cases. you have alkene over there which is going to be formed. This is the preparation method, that's fine. But one more molecule which is going to be eliminate, यहाँ पर एक molecule eliminate भी हो रहा है अलग से, which is HBr or water vapors हो सकते हैं या HBr हो सकता है, यहाँ पर एक अलग से molecule eliminate भी हो रहा है. That is why this reaction or these reactions are known as elimination reactions. All right, these are elimination reactions, right? Whenever there is elimination of water molecules, specifically, you can call this reaction as elimination reaction. That's fine. आप इसको elimination reaction बोल सकते हो. Or when there is a removal of water molecules, especially for the second one, so इसको आप dehydration भी कहते हो. So इस reaction को आप dehydration भी बोल सकते हो और elimination भी बोल सकते हो, जबकि ऊपर वाले को आप सिर्फ और सिर्फ elimination ही कहोगे. Is that clear, every one of you?
Yes, sir.
Now, let's talk about some examples. Now, very, very important thing about this reaction is what you need to understand this thing. For suppose, मेरे पास एक molecule है, just like this. ये एक molecule है मेरे पास कोई. For suppose, यहाँ पर एक CH3 लगा हुआ है. For suppose, यहाँ एक CH3 लगा हुआ है. यहाँ पर आपके पास OH लगा हुआ है. ठीक है ना? यहाँ आपके पास CH3 लगा हुआ है. यहाँ आपके पास CH3 लगा हुआ है. यहाँ आपके पास CH3 लगा हुआ है. ठीक है ना? यहाँ H, यहाँ H, यहाँ H, यहाँ H. For suppose I just want that कि मैं इस molecule में से ये OH remove कर दूं. I just want that कि मैं इस molecule में से ये OH remove कर दूं. So मेरे लिए removal तब ही possible है, the removal of hydroxyl or for suppose bromine. अगर आपके पास यहाँ पर bromine लगा हुआ है या chlorine लगा हुआ है, whatever the halogen over here, halogen alkane हो आपके पास या आपके पास alcohol हो, उन दोनों में से ही bromine हटाना हो या chlorine हटाना हो या hydroxyl हटाना हो, if you want to remove this, so it is compulsory over there कि इसके बराबर वाले कार्बन पे इंडिविजुअल हाइड्रोजन होना चाहिए. ठीक है ना? इसके बराबर वाले कार्बन पे इंडिविजुअल हाइड्रोजन होना चाहिए. बताएंगे इसके बराबर वाले कार्बन पे क्या इंडिविजुअल हाइड्रोजन है? This is individual hydrogen or CH3?
CH3.
Yes. So CH3 is not individual hydrogen. It is actually the hydrogen connected with the other carbon, right? This is the carbon which this is the hydrogen which is connected with the other carbon. So you need to keep remember कि अगर एक कार्बन है जिस पर हाइड्रोक्सिल लगा हुआ है, एक कार्बन जिसके ऊपर हाइड्रोक्सिल लगा हुआ है, उसके बराबर वाले कार्बन पर, इसके बराबर वाले कार्बन पर आपके पास एक इंडिविजुअल H होना चाहिए. अगर H ही नहीं होगा तो सिर्फ OH हट जाएगा तो पानी कैसे बनेगा? दूसरा ये कि डबल बॉन्ड आपने बनाना है दो कार्बन के बीच में, तो अगर एक कार्बन से OH हट गया तो दूसरे कार्बन से H भी हटना चाहिए ताकि दोनों कार्बन का एक एक इलेक्ट्रॉन फ्री हो और वो दोनों मिलकर बॉन्डिंग बन लें, डबल बॉन्ड बना लें. बट राइट नाउ अगर सिर्फ OH हट जाएगा तो दूसरा कार्बन तो उसके पास तो इलेक्ट्रॉन है ही नहीं फ्री, तो वो बॉन्डिंग कैसे करेगा, डबल बॉन्ड कैसे बनाएगा? This is the problem. So you need to keep remember, अगर आप Br हटा रहे हो, Cl हटा रहे हो या OH हटा रहे हो तो बराबर वाले कार्बन से H हटाना जरूरी है. अगर बराबर वाले कार्बन पर H नहीं है तो फिर हटाना पॉसिबल नहीं है. Is that clear बच्चों?
Yes, sir.
So you can say that the elimination can only be possible. Elimination can only be possible when adjacent carbon have individual H, right? When adjacent carbon has individual hydrogen atom. Is that clear, bacho? This is the main point you need to keep remember. If there is no individual hydrogen to the adjacent carbon have, that means there is not possible elimination reaction. So elimination reaction possible तब होगा जब बराबर वाले कार्बन पर आपके पास H मौजूद होगा. अब इसी कार्बन पे H मौजूद है तो ये कोई फायदेमंद बात नहीं है, क्योंकि अगर इसी कार्बन से OH भी हट जाएगा और इसी कार्बन से H भी हट जाएगा तो इसी कार्बन के दो इलेक्ट्रॉन फ्री हो जाएंगे. तो बॉन्डिंग एक ही कार्बन के दो इलेक्ट्रॉन फ्री होने से नहीं होती, पाई बॉन्डिंग तब होगी जब दो कार्बन के पास एक एक इलेक्ट्रॉन फ्री होगा. इज दैट राइट और नॉट?
Yes.
Right बच्चों or not? So for suppose I have this molecule, अगर मेरे पास ये molecule होता, यहाँ पर हाइड्रोक्सिल होता, यहाँ भले से CH3 लगा होता, यहाँ भले से CH3 लगा होता बच्चों, अगर यहाँ पर एक हाइड्रोजन होता, ठीक है ना, और यहाँ पर भी CH3 अगर मैं लगा दूं, ठीक है ना, अगर ये मेरे पास मॉलिक्यूल होता, so you can see this, अगर मैं इनको कंडीशंस देता, अगर मैं इसको कंडीशन प्रोवाइड करता, so that's fine कि इस कार्बन पे OH है, इसके बराबर वाले कार्बन पे देखें इंडिविजुअल H मौजूद है, तो ये दोनों रिमूव हो जाएंगे। so you can see this कि आपके पास ये कार्बन, ये कार्बन, ये कार्बन अपनी जगह पर मौजूद है, इन कार्बन्स को कुछ नहीं हो रहा है, ठीक है ना, ये CH3 अपनी जगह मौजूद है, ये H अपनी जगह मौजूद है, ये CH3 अपनी जगह मौजूद है, ये CH3 अपनी जगह मौजूद है। Now there will be a double bond when it remove hydroxyl and H plus water will be eliminated. Is that clear, बच्चों?
Yes, sir.
This is the thing to remember. Any problem about this? Any problem about this, बच्चों?
No, sir.
चलें, एक मेरे पास एक एग्जाम्पल है, बहुत मजे की एग्जाम्पल है, उसको देखते हैं। उस एग्जाम्पल को जब आप करेंगे तो आपका शायद सोचने का तरीका थोड़ा सा चेंज हो जाएगा। जस्ट लुक एट ओवर हियर, फॉर सपोज आई हैव अ मॉलिक्यूल 1 2 3 4 carbons I have, right? And for suppose I have hydroxyl over there and the rest of all carbon have H's, right? So these are H, different H's over here, right? So what happens if I provide the conditions to remove hydroxyl along with hydrogen? So what are the possibilities? What are the possible structures that form? So just look at over here, bacho. For suppose if I am removing this OH along with this H, right? So we know that क्या होगा आपके पास? The double bond will form in the center, right? So it will be 1 2 3 4 carbons. This H and OH will be removed, so it will have double bond, and the rest of all H are on their own positions. Is it right or not?
Yes, sir.
And one more possibility is this: maybe this H and OH will be removed, so it will be like this, that you will have double bond on the first carbon, right? So this will be like this. What do you say, bacho? Is this right or not? Right or not?
Yes.
Yes, sir.
So there are two possibilities. Actually, this is known as butene. This is known as butene. This is butene, and this is actually but1ene. Is that right, bacho, or not?
Yes, sir.
Now, one more thing to remember is whenever we talk about butene, there is one more structure of butene, which is cis and trans structure. We have not done yet the isomers of this, but definitely once we talk about this, so you will understand what is cis and what is trans. But right now, I just want to show you that whenever butene we talk about, so it will have two different structure. One is cis and one is trans. So we can even draw it like this in opposite directions. So these are actually three possible structure of this. One is known as whenever you have both the same structure, both the same species on the same side. So it is known as what? Cis butene, right? And whenever you have it in the diagonal form, so it will be known as trans structure. And right now we have butene, so it is butene, and this is having no possibility of this structure. So you can say that it is simple but1ene. This is actually what you can call this as geometrical isomers. These are actually geometrical isomers known as cis and trans. These are known as geometrical isomers, right? Geometrical isomers are only possible when you have carbon-carbon double bond. The first possibility for geometrical isomers is carbon-carbon double bond. So you can see this in both the cases, or in all three structures, we have carbon-carbon double bonds. So the geometrical isomers is possible, right? And the second possibility, or the second statement that you need to keep remember for geometrical isomers, is that both the carbons having carbon-carbon double bond at least have one similar species. So you can see this, that over here we we have similar species on both the carbon. That's fine. The second statement is also going to be fine over here, is going to be true over here. But the third statement is you need to keep remember, if you talk about carbon carbon double bonds, so if you just talk about one carbon between जो आपके पास कार्बन कार्बन डबल बॉन्ड है, उनमें से जो एक कार्बन है उसके पास दो एक जैसे स्पेशीज नहीं होने चाहिए, राइट? जस्ट लुक एट ओवर हियर, इस कार्बन के ऊपर दो एक जैसे स्पेशीज हैं, तो जब दो स्पेशीज एक जैसे आ गए, so it cannot show geometrical isomers. But if you talk about this one, so it has CH3 and H, and over here CH3 and H. देखें ये तीनों आपकी जो स्टेटमेंट्स हैं उसको फॉलो कर रहा है. कार्बन कार्बन डबल बॉन्ड भी है, दोनों कार्बन जिन पर डबल बॉन्ड है उनके पास एक एक स्पेशीज सेम भी है, और तीसरी बात ये है कि एक ही कार्बन पर दो अलग अलग स्पेशीज मौजूद हैं. तो तीन स्टेटमेंट पूरी कर रहा है, तो इट कैन शो ज्योमेट्रिकल आइसोमर्स. तो आप क्या करेंगे, दोनों CH3 को एक तरफ लगा देंगे तो cis, और दोनों को अपोजिट लगा देंगे तो इट विल बी trans. I'm not going to talk about further about this topic, geometrical isomers, because I told you once we complete all the functional groups, then we talk about isomers, right? So this is what the one of the question that you need to keep remember. Now the thing is, how can we remove this? How can we do this? So the statement, the reagents, conditions, and all things are over here. How to remove? This is important. How to remove water molecule or HBr or HCl molecule. So you need to keep remember, for suppose you have carbon carbon single bond, along with you have hydroxyl and H, right? If you want that ये दोनों remove हो जाएं, so what you can do for this, आपके पास आप चाह रहे हो कि alkene बन जाए ethene along with water molecule, तो ये कैसे possible है? So इसके लिए reagents आपने याद करने हैं बच्चों. reagents क्या यूज कर सकते हो आप इसके लिए? सबसे पहले तो आप याद रखें कि आप इसमें concentrated sulfuric acid यूज कर सकते हैं, और इसकी कंडीशन क्या होगी? इसकी कंडीशन होगी 200 डिग्री सेंटीग्रेड टेम्परेचर, right? This is the reagent and condition for this reaction, and we know that the type of reaction is, this is dehydration because you are removing water molecule, or you can even call this as elimination reaction, right बच्चों?
Yes.
Right? Or we have one more alternative as well. We have one more alternate condition and reagent. For suppose you are living in that part of the country where sulfuric acid is not available, for suppose, so you can even use aluminium, right? Which is actually aluminum oxide. You can use this as well, right? And the condition, once you are using aluminum oxide, so the condition for the reaction is you need to use 350 degrees centigrade temperature. Is it right, Bachcho?
Yes.
Now, for suppose, if you are going to do the elimination reaction of HBr, so if you are removing right now over here water molecule, and for suppose over here you need to remove HBr or HCl, right? For suppose you need to remove HBr or HCl, so how can you remove this, right? How can you remove this? For suppose you have one of the molecule, H and Br is over there, and you want that this HBr is going to be removed, and you will have what? Carbon carbon double bond, ethene you will have along with HBr molecule. So how can you remove HBr? So if you want to remove HBr, so we have different conditions for this, right? So the reagent should be NaOH, right? The reagent would be NaOH, or even you can use KOH, both are the same things, right? But the condition is you must use them in ethanol, right? So you can say that ethanolic NaOH or KOH you need to use, right? Or heat under reflux. इसको साथ साथ करना है आपने, and कर लेते हैं इसको, and heat under reflux. यानी कि ये आपने तब तक करना है जब तक ये completely process ना हो जाए, right? You need to keep remember, we cannot use water over there. If you use water, so it will be something else, right? और ये हम पढ़ेंगे next chapter में कि water use करने से क्या होगा, NaOH in water use करने से क्या होगा, ठीक है ना? अभी हम NaOH aqueous use नहीं कर सकते. You need to use NaOH या KOH ethanolic, इथेनॉल में होना चाहिए, पानी हरगिज नहीं होना चाहिए. You need to keep remember this. And the type of reaction we know, again, it is elimination reaction. Am I clear to every one of you?
Yes.
Is that clear? Now let's talk about the procedure. If you talk about the procedure, ये हो कैसे सकता है? So if you remember, हमने कल एक पिक्चर देखी थी और उस पिक्चर में ये रहा. You can see this. This is the process जहां पर आपको साफ नजर आ रहा है कि आप ये प्रोसेस कैसे कर सकते हो. This is the process, right? Yes. ये रहा आपके पास प्रोसेस, ये आपके सामने है, आप इस तरह इसको कर सकते हैं, राइट? जस्ट लुक एट ओवर, दिस इज एक्चुअली द प्रोसेस. जिस तरीके से आप इसको कर सकते हो, प्रोसेस को प्रैक्टिकली कर सकते हो, ठीक है ना? सो राइट नाउ जस्ट लुक एट ओवर इन द प्रोसेस. यू हैव व्हाट, दिस इज एक्चुअली, दिस वन इज मिनरल वुल सोक्ड विद इथेनॉल, राइट? इसका मतलब ये है कि इसके अंदर इथेनॉल मौजूद है, राइट? And you are using pumice over here. For example, you can consider this as aluminum oxide as well. आप इसको aluminum oxide लिख सकते हो, right? You are heating over here, strong heating. You can see this. If you are using aluminum oxide, so you at least you need to provide temperature 350, right? Once you are doing this, definitely this ethanol is going to convert into water and ethene. So this ethene will move from here. It will go over here, go over there, go over there, and it will is bubble over here. We know that why it is bubbling, because ethene is actually insoluble in water because it is a non-polar. So it is insoluble in water, so it will bubble and start collecting over here. Is that right, bacho?
Yes, sir.
So we can write the balance equation for this reaction. You know that. What is this? This is actually C2H5OH ethanol. You are heating this, right? And it is going to form C2H4 along with the elimination of water. Is that right or not?
Yes, sir.
So what is the name of this reaction, bacho?
Elimination?
Yes, you can call this elimination, and the very good name is dehydration, because the water elimination is dehydration, right? Or even you can call this elimination, right? And they are saying that give the chemical name of the reagent other than pumice that could be used to carry out this reaction. It is not necessary to use the same apparatus, right? We can use that concentrated sulfuric acid as well, right, bacho? Or not? Is that right?
Yes, sir.
Okay, thank you so much. Then, bacho, for suppose, I just want to check your skills now. So, what is about your skills? So, let's have a test of your skills now. So, there is a skill test for you. So, for suppose, I have a molecule having, for suppose, 6 to 7 carbons, right? And over here we have hydroxyl. Over here we have hydroxyl, right? And over here we have, for suppose, CH3, and the rest of all we have hydrogens, right? And the rest of all we have hydrogens, right? For suppose, but I am providing the required conditions, which is actually right now we know that at least 200 degrees centigrade temperature along with concentrated sulfuric acid. So, bacho, what will be the product? Can you please tell me what is the product when you do this? So what will be the product? Can you solve this? Also, I want कि आप इसको भी solve करें. This is skill test number 1, right? And now skill test number 2 is, for suppose we have this molecule, right? And this molecule we have hydroxyl and CH3 over here, right? If I am heating this after 200 degrees centigrade along with concentrated sulfuric acid, so what will be the possible product? Can you please tell me? Yes, do it quick and send me the message on my WhatsApp so I can check you are getting things funny. Okay, these are the question will be solved like this. The simple is that आप देख सकते हो यहाँ पर कि this carbon having hydroxyl on adjacent carbon we have hydrogen, and same as it is over here as well. So we can do in this way that we have 1 carbon, 2 carbon, and double bond over there, then carbon and double bond over here, right? And this carbon, it will be having hydrogens, it will having CH3, it will be having hydrogen, 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 hydrogen. This will be the molecule as much as you have hydroxyl over there, and if the adjacent carbon having hydrogen, so definitely the water molecule will be eliminated, right? Same as it is if you talk about this structure, bacho. So just look at over here, if I draw it in the displayed form. So 1 carbon, 2nd carbon, 3rd carbon, 4th carbon, 5th carbon, 6th carbon, and 7th carbon. Over here we have hydroxyl, and over here we have 1 more carbon having H's. And definitely it has H, 2 H's. It also had two H's, 2 H's, 2 H's. Is that right, bacho, or not? Right. So just look at over here, bacho. For suppose if you talk about this carbon having hydroxyl, so the adjacent carbon having signal H, individual H, so they both can remove. They both can remove, and you will have what? The double bond over here, right? So you can even draw like this, sir. The structure will be like this. The hydroxyl will be removed, and the structure will be like this, right or not, bacho?
Yes, sir.
One more thing, just let's talk about this one as well. आप सबने सोचा नहीं इसको इस तरह क्यों नहीं सोचा? You can even think about this, बच्चों, that this carbon if having hydroxyl, so its adjacent carbon also having H, so even these two can remove, right? So we have double bond over here, so the structure can be like this, right or not, बच्चों? Right or not?
Yeah.
And one more thing, you need to think about this as well. आपने ऐसा क्यों नहीं सोचा that if you focus over here, so this carbon having hydroxyl and the adjacent carbon having H, so even they can remove these two as well. So the structure can be like this as well. If you talk about this structure, so the structure can be like this as well. What do you say, bacho? Is that right or not?
Yes, sir.
So these are the things that you need to think about over here. यहाँ पर आपने कुछ इस तरह से कुछ अलग सोचना है, ठीक है ना? आपने कुछ इस तरह से कुछ अलग सोचना है, और आपने सारी पॉसिबिलिटीज बतानी है. This is the first possibilities, this is the second possibility, and this is the third possibility that you can write or you can draw. Am I clear to every one of you?
Yes, sir.
Okay, so this is all about today's lectures. Let's see how one of the example question that we were talking about last class, and we have few pictures of these questions as well. So if you talk about this question, just look at over here what they are saying. We talk about molecular formula, we talk about the reaction with bromine, we talk about the a type of reaction, and they are talking about draw the structure formula of the compound from when cyclohexene is reacted with hot concentrated camphor. I told you that it is not done right here. We are leaving this point right now. So let's talk about some more pictures. This will be the picture, one of the picture. You can see this. Give the structure of organic compound. We have did that in the last class. Give the structure of organic. We did that, right? So I'm removing this as well. And this one we already talked about in today's class, right? Or yes, we already talked about this one as well. So मेरा नहीं ख्याल है अब कुछ बचता है. We already completed this. We will talk about some past papers in the next class, inshallah. We will do some past papers of alkenes in the next class, inshallah.